Hello, welcome to this new session. Today, session number 2. Yesterday, we saw the search API, and today we are going to cover the analysis process, which is happening behind the scene. So let's start here. I have some text fields because it's all related to text content. So I have the title, category name, text, author, etc. So if we look at what we have, for example, this grok parse failure problem in the title. So let's search for grok parse failure here. As you can see, we have that number of hits, 15. But maybe you noticed actually that I was using the underscore grok parse failure. Do we have that here? So if I'm searching for that in the title, I don't have the underscore grok parse failure, right? So let's search for it. If we search for it, we can find that information, but then we don't find the other way to write it with or without the underscore. And the reason for that is because we are doing text analysis behind the scene. And text analysis is a critical part when you are doing text-based search. So let's dive a bit into it. So if I'm looking at the field title, and I'm using here the underscore analyze API. On the field title, I want to parse this underscore grok parse failure to understand what is happening at index time and what is happening at search time. We are using the same analysis process on text fields. So here I can see that underscore grok parse failure is actually indexed that way with the underscore, while grok parse failure is indexed or searched that way without the underscore. Which means that when we are searching for underscore grok parse failure, it will match only on underscore grok parse failure. But when we are searching for grok parse failure, it won't match with that one. That's one of the problems. The reason for this is because this behavior, is because we are using the standard analyzer. And if we look at what the standard analyzer is doing behind the scene, that's exactly what I explained. It's producing the underscore grok parse failure on that text and the grok parse failure on the other text, right? So we have two different terms in our index or when we search, and it does not mean the same thing. By the way, we can see that the standard analyzer is also lowercasing our content, so problem is now lowercase. So if we look at the analyzer and what is an analyzer actually, so an analyzer is described in the documentation here. So it's made of several building blocks. So it's 0 or more character filters, and those are responsible to transform a stream of characters by adding, removing, or replacing characters, or to strip HTML elements from the text, which is interesting in our case because you might have noticed that the question and the solution might be in HTML, so we might use that. You need one tokenizer, no more than one, but you need one at least, not at least, you need one. And the tokenizer splits the stream into tokens depending on its implementation. And then you can have 0 or more token filters, and they are working on the token stream, and they can modify, they can add or remove new tokens. This is what we are doing. If we look at the standard analyzer here, so we have a list of built-in analyzer. This is the reference here. And you can use all those ones. If you don't want to use any of those ones, you can have your custom analyzer. But let's have a look at the standard analyzer. So the standard analyzer, you have the full configuration at the end. If you want to reproduce what the standard analyzer is doing, it's built with a standard tokenizer and a lowercase token filter. Right. And this is exactly what I'm reproducing here. So with the standard tokenizer and the lowercase token filter. So I have exactly the same behavior as we saw. And now what I want to do, I want to change the way the text is tokenized because I want to have both things matching. So instead of using the standard tokenizer, I'm going to use here the char group tokenizer, and I want to tokenize on white space and punctuation. And this is giving me the result I'm expecting here. So grok parse failure, underscore grok parse failure is now tokenized as grok parse failure and the same thing will happen. So it will match at the end. So this is exactly what we want to have. If we look at the HTML content that I mentioned, so in the text we have some HTML content, we need to get rid of those elements. So let's take this text into account with the behavior that I set before. If I'm searching for Bing, it's not going to match because, as you can see here, the token that I have is with some kind of HTML element. So we need to remove that. And to remove that, we can add the HTML strip character filter. And this is going to remove all the HTML elements that we don't need here at index time. Okay. One of the things you can also do if you want to understand exactly what is happening behind the scene, you can add this explain true to the analyze API, and it will cover step by step what is happening. So you can see here the effect of the HTML strip char filter. It removes basically the HTML content, and then you can see the other steps. Okay, so what if I have now issues and issue with that configuration of the analyzer? Let's have a look at that. It's going to produce two tokens. So if I'm searching for issue and I have index issues, it's not going to match, right? So instead, what you can do is to use an English themer that you can configure here as a token filter. And when you configure that as English text, it will generate issue without the E at the end for this text, and the same token for issues. So both terms then will match at search time, whatever you have indexed at index time. One of the things you can do as well, if you have some path, like here, I have the field avatar template, which is a path actually, and I have this example here. So if I'm analyzing this content, if I'm tokenizing that as is, I'm using a keyword tokenizer behind the scene, so it does not do anything, just keep it as is. It will be hard to search within the path or to do anything related to the path. For that, you have a specific tokenizer named path hierarchy, which is super handy because it's going to go through the path until the end of the stream. So you have all the different versions of the path that you can that you want to have from the start. And then how you can do search as you type. Let's say that I want to analyze with the simple analyzer. The simple analyzer is basically lowercasing your content, a bit more than that, but let's say that. So here, if I want to search for a user which name starts with DADO, but I have indexed only this text, Dadone, it's not going to match. So don't use wildcard queries or anything like that, that we might cover tomorrow. But instead, you can change the behavior of your analyzer and use here a edge-and-gram type of token filter. So for this text, at index time, instead of indexing only this full term, I will index sub part of the term. So if I'm searching then for Dado, then it will match this way of representing this value. So I will be able to find the data I'm looking for. So I have basically reindexed everything in a new index, name now ByteDiscuss02. And if I'm searching again, like I did at the beginning, in the title field for this underscore grok parse failure, I have now 40 documents. And as you can see, underscore grok, underscore grok, underscore grok. And now I have the grok parse failure, which is matching, because I'm using the same strategy that I explained during this session. So tomorrow, we will be covering the most important queries you need to know about text search. So don't forget to subscribe to this channel. Have a good day. Bye.